In section 1.6, we look at equations and inequalities involving absolute value. So let's start with the definition of the absolute value. We say that the absolute value of a real number x is equal to x if x is greater than or equal to 0 and is equal to negative x if x is less than 0. Now let's translate x is less than 0. What that means is negative. And when we say x is greater than or equal to 0, it means non-negative, right? Because it can be 0 or positive. So we're saying that if x is a non-negative number, the absolute value of x is x itself. And if x is a negative number, then the absolute value of x is the opposite of x. Now, why is this the definition? Well, it's because the meaning of absolute value is it is the distance that the number x is from 0. So if you were to take a look at a number line, here is the number 0. If I have a number here, then the absolute value of that number is that distance. So if this number is x, then this distance here is the absolute value of x. And if I have a number over here, it's the same concept. Let's say that this number over here is y. The absolute value of y is the distance that y is away from 0. So basically, if your number is negative, since the distance can't be negative, we need to turn that number into a positive. And that's what this negative does right here, right? If x is a negative number, then the opposite of that negative number will be a positive number. Couple of basic examples. If I were to ask, what is the absolute value of 4? Well, that would be the distance that 4 is from 0, which is 4. The absolute value of negative 5, that's the distance that 5 is from 0, which is 5. But if we use the definition says that when you have a negative number, the absolute value of that number is the negative of that number. So if I use the definition, this would be negative 5, which is 5. So that's how that definition works. Now let's talk about solving equations. When you have an equation involving absolute value, this is the procedure that we use. So let's assume that a is a positive number, right? A is greater than 0. The expression absolute value of x is equal to a means that x has to either be a or x has to be negative a. Now let's understand that real quick. If I say the absolute value of x is equal to 5, then that means that x is 5 units from 0. On a number line, here's 0. If we go 5 units to the right, that's positive 5. If we go 5 units to the left, that's negative 5. So the only way the absolute value of x can equal 5 is x would have to be 5 or x would have to be negative 5. That's exactly what this is saying right here. Now let's talk about how to solve some of these equations when the expression inside the absolute value is not just a variable like x. So in our first example, we have the absolute value of 2x minus 3 is equal to 7. So if we think of 2x minus 3 as being some number, we're saying that the distance that this number is from 0 is 7 units. The only way that can happen is if 2x minus 3 is equal to the number 7 itself, or if 2x minus 3 is equal to the number negative 7. So now all we have to do is solve both of those equations and we'll have two answers. So here, if I add 3 to both sides, we get 2x is equal to 10. And then dividing by 2, we get x equals 5. In the other equation, when we add 3 to both sides, we get 2x is equal to negative 4. And then dividing by 2, we get x equals negative 2. So the solution is x can either be 5 or negative 2. And you can write the answer that way. You could write the answer like this. And sometimes what they'll do is they'll even write the answer as a solution set, like this. Okay? Now, let's understand this, though. I'm going to go through and check these answers. So let's see, is x equals 5 really a solution? Well, if it is, then when I plug in x equals 5 into the original equation, it should make it true. Well, 2 times 5 is 10. So we have the absolute value of 10 minus 3. That's the absolute value of 7. And of course, the absolute value of 7 is 7. So that checks. Now let's check negative 3. So if x is equal to, I said negative 3. If x is equal to negative 2, let's check that answer. We get the absolute value of 2 times negative 2 minus 3 is equal to 7. Well, 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. And the absolute value of negative 7 is 7. So you can see that both answers check. Let's take a look at the next problem. So next we have the absolute value of x is equal to negative 3. So let's stop and think about this for a minute. X is a number. The absolute value of x is the distance that number is from 0. So what we're saying here is that we have a distance, and that distance is equal to negative 3. This is not possible. Okay, and the reason this is not possible is because a distance cannot be negative. Distance has to be at least 0 or a positive number. So since it's not possible, this equation has no solution. So in the last problem, we have a more complicated equation. We have negative absolute value of 3x plus 1 minus 3 is equal to negative 8. So what we need to do first here is isolate the absolute value. So we need to get this expression by itself. First, I'll add 3 to both sides. And this gives us negative absolute value of 3x plus 1 is equal to negative 5. Now you have to pause for a minute here because in the last problem we said that it was impossible for an absolute value to equal a negative number. However, in this problem you'll notice we have a negative sign in front of our absolute value. That's actually the number negative 1 multiplied by the absolute value. So I'm going to divide both sides by negative 1. And this will cancel the negative 1 here and cancel the negatives here. And that will leave us with the absolute value of 3x plus 1 is equal to positive 5. Now this is possible. So to solve this, we know that 3x plus 1 has to be either 5 itself or 3x plus 1 has to be the opposite of 5. Solving by subtracting 1 from both sides. In the first equation, we get 3x equals 4. Finally, dividing by 3, x equals 4/3. And in the second equation, subtracting 1 from both sides, we get 3x equals negative 6. And then dividing by 3, we get x is equal to negative 2. So x equals 4/3 or negative 2. Now let's move on to absolute value inequalities. First, we intend to understand the concept. So we're going to assume that a is a positive number, and we have the inequality absolute value of x is less than a. Now, it says this is equivalent to x is between positive a and negative a. Let's understand why. Again, absolute value represents distance. So if x is a number whose distance from 0 is less than a, then that means the number x can be no more than a units to the right of 0, and it can be no more than a units to the left of 0. And that means it has to be a number between positive a and negative a. In a similar way, if a is a positive number, the inequality absolute value of x is greater than a, means that the distance that x is from 0 is more than a units from 0. So here is the number 0. If you are more than a units from 0, that means you have to be at a or farther away. Or equivalently, you can be at negative a or farther away. So the equivalent expressions for absolute value of x is greater than a is x can either be less than negative a, or it can be greater than positive a. And then they do mention that if you have an equal sign included with your inequality, you basically set it up the exact same way, but if you have an equal sign, you have to make sure you put equal signs when you set it up. Let's do a couple of examples. In the first example, we have the absolute value of 2x minus 3 is greater than 7. So we're saying that something has to be more than 7 units away from 0. So let's understand what this is saying. If 0 is here, positive 7 is here, and negative 7 is here. To be more than 7 units away to the left means that the number would have to be out here. And to be more than 7 units away to the right, the number would have to be out here. So it's either less than negative 7 or it's greater than positive 7. Now, when I say it, I'm referring to whatever is inside the absolute value. In this case, it's 2x minus 3. So either 2x minus 3 has to be less than negative 7, that's this part, or 2x minus 3 has to be greater than positive 7, which is this part. And now we just need to solve these simple inequalities. So here I can add 3 to both sides, which gives us 2x is less than negative 4. And then finally, dividing by 2, we get x is less than negative 2. Or, if we solve the other inequality, we add 3 to both sides, we get 2x is greater than 10, and then dividing by 2, we get x is greater than 5. So here is our solution in inequality notation. Now, on a number line, what that means is that x is less than negative 2, or x is greater than positive 5. So in interval notation, our answer will look like this. And most of the time, you will be asked to put it into interval notation. In the next example, we have the absolute value of something is less than or equal to 5. So again, let's understand what that means, generally speaking. It means that you have some number and its distance from 0 is less than 5 units. Well, 5 units to the right of 0 would be here, 5 units to the left of 0 would be here, and if that number is less than 5 units away, that means that it has to be in between positive 5 and negative 5. And in this case, we'll also be including the endpoints because we have an equal sign there. So now how do we set this up? Well, the number we are referring to is whatever's inside the absolute value sign. So what we have is the number negative 2/3 x plus 4. That number has to be less than or equal to 5, but also greater than or equal to negative 5. And now we just need to solve this compound inequality. Now, there's a couple of ways to do this. I'm a fan of getting rid of fractions whenever you can. You don't have to. You could subtract 4 from both sides, or from all 3 parts, actually. But again, I like getting rid of the fractions, so I'm going to multiply everything by 3. 3 times negative 5 is negative 15. 3 times positive 5 is positive 15. And in the middle here, 3 times negative 2/3 x is going to leave us with negative 2x. And 3 times positive 4 is positive 12. So it kind of got a little bit obscured there, but there is a negative sign there, right? So that just comes down there. Next, I'm going to subtract 12 from everything. This gives us negative 27 less than or equal to negative 2x less than or equal to 3. And now, finally, to solve for x, I have to divide by negative 2. And that means I have to divide everything by negative 2. But remember, this is an inequality. So when you divide by a negative, these inequality symbols must reverse. It's very important we realize that. And now we can simplify 27 over 2. Negatives cancel. We get x in the middle, and we get negative 3 over 2 on the right side. And now I want you to notice that this inequality is now backwards. We're saying x is bigger than negative 3 over 2, but smaller than 27 over 2. So what I'm going to do is flip the inequality around, putting this number on the other side and this number on its other side. And when I do that, I can reverse the inequalities back to the way that we are used to seeing them. And so this is our answer. X must be a number in between negative 3 halves and positive 27 halves. And on a number line, we have the two numbers there, and x must be a number in between those two numbers or including those two numbers. So in interval notation, it looks like this. Now let's take a look at the last example. So here we have negative 4 plus the absolute value of 3 minus x is greater than 5. First thing we need to do is isolate the absolute value. So I'm going to add 4 to both sides. This gives us the absolute value of 3 minus x is greater than 9. Okay, now that we have the absolute value isolated, we're going to think about what this means. So let's draw a number line. Whatever's inside the absolute value, we'll just think of that as some number. And we're saying that whatever this number is, its distance from 0 is more than 9 units away. So here's 0, here's positive 9 and negative 9. If the number is more than 9 units away, it either has to be a number here or it has to be a number here. So the number has to be less than negative 9 or greater than positive 9. Now, what's the number? Well, it's 3 minus x. So that number 3 minus x must be less than negative 9, or 3 minus x must be greater than positive 9. And now we just need to solve for x in each of these. So I'll subtract 3 from both sides. This gives us negative x is less than negative 12. And once again, we have to divide both sides by negative 1 to solve for x. And when we do that, you must reverse the inequality. So we end up getting x is greater than positive 12. Or the other answer, if we subtract 3 from both sides, we get negative x is greater than 6. And then once again, dividing both sides by negative 1, we get x is less than negative 6. Right? Because again, you must change the direction of the inequality symbol when you divide by a negative. Now on a number line, positive 12 is here, negative 6 is here. If x is greater than 12, that would be these numbers. And if x is less than negative 6, that would be these numbers here. And so in interval notation, we have the answer written in the following fashion. So again, you can either write your answer like this or like this, but usually interval notation is preferred. Now we're just going to focus in on distance. So we already know that the absolute value of a number is the distance that the number is from 0. So here it says, graph the following on a number line and write each set using absolute value inequality notation. So we want to talk about the set of all x whose distance from 4 is less than 5. Okay, so let's draw a number line. We have the number 4 here, and we want to draw all the numbers x whose distance from this number 4 is less than 5. So if you go 5 units to the right, that's going to take us to the number 9. And if you go 5 units to the left, that will take us to the number -1. So what we have there is x must be a number in between 9 and -1. So that should make sense, right? Because if x is a number in between here, it is less than 5 units from the number 4. But we want to write this in absolute value inequality notation. So let's remember that the distance between two numbers, a and b, is nothing more than the absolute value of a minus b. So if I want the set of all numbers x whose distance from 4 is less than 5, then I want the distance between x and 4 to be less than 5. Well, the distance between x and 4 is the absolute value of x minus 4, and that needs to be less than 5. So this is how we would write this thing here in absolute value notation. Now the second part of this problem, they just want you to write the set of all x whose distance from 4 is greater than 5. So once we understand what we did for the first part, all we have to do for the second part is change this less than symbol to a greater than symbol. So this absolute value expression says the distance between x and 4 is more than 5 units. And for the last example here, it says a thermometer measures temperature with an uncertainty of 0.25 degrees Fahrenheit. If a person's body temperature is measured at 98.3 degrees Fahrenheit, use absolute value notation to write an inequality for the range of possible body temperatures. Okay, let's look at a number line. The middle of our number line is going to be the measurement of the body temperature, which was measured to be 98.3 degrees. Now, the uncertainty of that measurement is 0.25 degrees Fahrenheit. That means the person's actual body temperature might have been 0.25 degrees Fahrenheit warmer, or it could be 0.25 degrees Fahrenheit cooler. So if I add 0.25 degrees to 98.3, that would be 98.55 degrees. And if I subtract 0.25 degrees from 98.3, we get 98.05 degrees. So if we let T be the actual temperature, then we know that T must be a value in between 98.55 degrees Fahrenheit and 98.05 degrees Fahrenheit. And actually, you know what? There's a little detail here. When we talk about temperature, this is my fault. Temperature is usually represented with a capital T, not a small t. Small t is usually reserved for time. So this is what t could be. It could be any one of these values here, okay? And it could be including these values as well. But we want to write this using absolute value notation. So if the error of the measurement is less than or equal to 0.25 degrees Fahrenheit, then that means the distance between the actual temperature and the measured temperature, that distance must be less than or equal to 0.25 degrees. And so this is how you would write that same thing using absolute value notation.